go through those problems and troubleshoot. So for today, I'm gonna share my screen and I'm gonna code with you. So I don't have a lot of things. I didn't have a lot of time to prepare this lecture, but I wanna show you like a few things that I have. So today, I wanna talk about admin functionalities, errors and cycles. So that's a very broad subject, but basically we'll start with admin management. So this is like basically having the ability to perform some operations on your canister with some whitelisted principles. So like, I'm gonna start with this canister. Maybe I should zoom, yeah. I think it's fine like this. So yeah, let's say you have a canister and you want to like upload assets, you want to make modification on the metadata or things like this that you just want to be the only person available that can do that. You don't want any external party to do it. So that's how you would do it. This is like the very basic solution, I would say. You just store the owner of the canister. So this is a principal. This is an identifier for your DFX identity. And you can use this syntax. Honestly, I don't have a tip to remember this syntax. I just like copy paste from past project. I think it's like, there is the echo. So yeah, if you use this syntax, you can get the color and then it's stored inside this variable, which is, you can name it whatever you want, but in this case, it's creator, and then you can store it here. So this will be the principal of the person that deployed this canister. And then, so we can try a few things. So I think I've named those canister in dfx.json. So the first one is called admin single. Let me just move this. Yeah. So if we do dfx deploy admin single, oops. Okay, it was pretty fast, but now we should be. Let me. It's not this one. It's this one. So now we should be able to check our identity. So let's say, who am I? So the name of this identity is Seb. Then I can check like the principal. So this is the principal. And I should get the same if I call this function. So get owner, because I was the one to deploy this canister. Or maybe it was my cycle wallet. We'll see. DFX canister call. So admin single. Get owner. Okay, so yeah, that's the same principle. So yeah, I've deployed this canister, so that works. And now I can call this admin function. So like, it's just gonna return hello admin, but we would imagine that you would perform actions like modification on the canister. So let's try it out. So that works. But now if I use like, if I switch my identity, I use defaults, for example, and I call the admin function, it's gonna trap, not a trap, it's gonna assert, oh, sorry, that's a trap, yes. The assertion will fail. So if you have something that is false, an expression that is evaluated to false in this assertion, it will trap, and so we don't execute the code that is here. So that's like pretty quick and dirty way to have admin functionalities inside your canister. The second exam that I have for you is a bit more elaborated. So it's the same like logic, but instead of having just one admin, I'm gonna store all of them inside an array. You should be able to do that with a buffer as well. It's probably better with a buffer, but I had this code and I was using array back then. So you can basically add them and you can just verify that whoever is an admin is only able to add more admins. So yeah, I think this code, I'm not gonna test it with you because I think you got the point. If you have questions, I'm checking the chat, so feel free to pose a question in live. So yeah, I wanted to show, it's a bit confusing because there is a lot of code, but I wanted to show real live like projects. So this is a Discord, which is the project that I was working on before. It's it was one of the biggest NFT projects, and so we had a lot of admin functionalities, and I wanted to show you like what does it look like for a real project. I think that's interesting. So basically, I had created this module. So yeah, maybe I have a few canisters. I'm just going to focus on this one. So like this is the avatar canister, which was the main canister with the main avatar NFTs. And so I have all those folders, which are modules. I have the main.mo. And the structure is pretty like simple. It's sorry, it's almost always the same structure that I was using. I was doing everything in modules. So like admin module, asset module, HTTP module, and so on. And then I was just importing the module in the main file and using the module like this, for example, public query isadmin was calling admin module, and then the isadmin function of the admin module. The biggest advantage of doing that is that you can easily test your modules. It's really hard to test things with Hacktor, like because you have to deploy it, you have to put a state in it. It's not something you can easily test locally, or like, yeah, it's really hard. Like you can only test it with end-to-end tests, so like just calling your canister and testing things. But if you have modules, so let's dive into the admin module, which I wanted to show you. If you have module, you can declare the type here with an interface. So that's already pretty clear. Like you have this module and you can do this thing, you can do this, you can call this function, you can call this function and this function on this module. And then you have the lib, and this is where you implement the interface. And that's pretty cool because it's really like, it's way easier to test that. You can implement that, for example, with nodes. You can call it easily. You can set up way more like test suites with those modules. And also it's just making the code like way more concise and clear once you got this pattern. Just one thing that I wanted to add is that, yeah, all my modules were, they were not stable. So like I was not using stable data structures. There was not a lot of access to stable memory back then. And so I was doing those pre-upgrade and post-upgrade methods that I'm going to talk about in the guide of tomorrow, but I can mention it today. No, sorry, it's the guide of today, but it's already online. Wait, no, I think it's the guide from tomorrow. But anyway, so basically my modules were automatically, so if I go here, I think it was here. Yeah, I just had like those system functions. So this function runs before the canister is upgraded, and these functions run after the canister is upgraded. And as you can see, because all modules had the same like pattern, like they had a pre-upgrade method and a post-upgrade method. So I could just write it like this, and that was pretty clear for me, like just calling that. So yeah, those methods were basically taking all the state from the module, putting it in a stable structure, so like an array basically, upgrading the canister, and then once the canister is upgraded, I take back the array and I instantiate the module again with the state that I had. If you have questions, feel free to ask them, because I can understand like there is a lot of code. Why use this symbol before variables? Where do I think I did. Oh, that's just a personal convention. Yeah, I was using that. It's not for variables, it's for the name of the modules. So it was a bit confusing because I had like, for example, let me find something. Yeah, I don't remember exactly. I had some issues with the modules and the names of the function in it. Like it was basically the same. And so what I decided to do is that all modules, I would use this this symbol before, so that I know if I see this with like a capital letter, I know it's a module and it's not like something that is a variable. Yeah, the tests. I can show a few things. I don't know if I have a lot here. I think I had a few things. I was not the best, like I was not the most like active tester on the IC. I think some people did more test suite than me. I don't think it's there though. Yeah, no. But I can post a few things maybe after on Discord, and also I think tomorrow or Saturday there is a lecture on tests from Quint, which has been doing a lot of good job on testing. I think he has new methods that are more efficient now. But basically, to test things with canisters, as far as I know, you can do like some scripts. So I can show like, okay, it was not part of my plan, but let's go. I can show you like how people would do it. So this is a repository from Aviat Labs, which is doing a lot of packages for Motoko. And if they haven't changed their like testing methods, I think they've changed a bit. Yeah, so there is like a simple way to test, which is what you can see here. Basically, you just write Motoko code and you have those assertions. So you verify something, like you execute something. And for example, for the SHA-224 method, you expect something, like you know that the result is going to be this. So you just do it and then you assert. And if the assertion is false, you know that something is wrong. And you can just execute this code with mock. So it's the Motoko compiler. It's going to interpret the code and just run that without having to compile and everything. That's really cool. But I would say that's the really basic way to test. Then you can do more advanced things. So I should have it in my Discord. Yeah, that's very messy, I think. So basically what I wanted to show you is you can set up a DFX, not a DFX, but an identity with Node. I think that's here. Yeah, so like I could, I mean, this code is online. I can give the link. I think someone already sent the link in the chat, but basically you can generate an identity for Node. And then once you can use Node, you can use some of the test suite. There are a few things to take into account with the IC, like for example, like you have this delay of update calls that is a bit annoying. If you're performing a lot of update calls, it's going to take a lot of time for your test to run. But I found that's the way I was testing mostly, was with Node, and doing like a few tests from that. And I think there are other ways, like I think there is a matcher library on Motoko, and there are more things now. I'm not 100% up to date on the test, so just gonna skip this question and move to the next one. So I have a lot of questions on tests. I'm not the best person to answer that. Can one write the testing code in the same file as the code it tests? I think you can, yes. It's gonna interpret your code. So like if you, yeah, I think I don't see why you wouldn't be able to do that. But I think it's like just cleaner to have like a source and just test folder. Usually that's the way they go for packages. Yeah. So I'm back to the lecture. I wanted to show you another thing before going back to the code. It's a really cool. It's there. This one. So for admin functionalities and like monitoring and logs, I found this library to be very useful. I wanted to show you, but I don't have access to my accounts and stuff here. But basically, it's a library that you just import, so you can use Vessel, and I think now you can use mops as well. So those are package manager for Motoko, and then you just like I think I have the code here. You just use canister geek, and then in your main.mo, you add the functions that are here. So metrics, canister. So you have a query that is a get canister metric, and an update that is a collect canister metric, and you have the logs, get canister logs, set max message counts, and all those functions are like you can find them here. You have all the instructions, so you just copy paste that into your canister. And then you have access to, I wish I could show it. I don't know if, maybe if I go on your, yeah, okay, that's what I was looking for. I thought he was gonna show the image. So yeah, if you, I hope you can see, but basically you can see like, no, that's not this one. This one is for users. Anyway, you have like a dashboard like this with your cycles, how much you consume like last day, how much you consume next week, last week. And it also does prediction based on like your activity in the canister. It's also doing things on the memory. So like it's checking how your memory is growing. If you're gonna encounter issues soon, it's gonna like send you warnings. So it's a user geek. It's they are doing packages and tools for the IC, and they have something for users like the rate of user growth and retention and stuff. But they also have things for like cycles and logs. Yeah, you can also access logs. And so the name of the packages is this one. User geek, canister geek, IC Motoko. I'm just sending the link in the chat. So I think I had this in all my canisters because it's like just take 2 minutes to do, and then you have information on cycles and stuff, and you can do logs, which are really useful to have. I was using it as a debug sometime tool. Not really like perfect way to go about that, but sometimes it was useful to have some place to log things directly on the mainnet. So I think that's it for the admin functions. Now I can move to the errors, the second topic. So the topics are not very related, like one to another. It's just like 3 topics that I've put in this lecture. So I'm talking about errors. It's how to handle errors in Motoko. And the best way to go about that is with the result type. So which has a module as well, the mo.base results. And then you can create. So basically, I think the type result is type result. We can go to the base library, I think, before I just like, write. Yeah, so the type result is defined with the type OK and the type error as well. And it's basically a variant. So it's either OK, which is of type OK, and error, which is of type error. What does it mean is that basically you can customize your result type, and you can say that if you have OK, you're going to return text, and if you have error, you're going to return an error message maybe that you can define in another place. You could also replace that with a NAT. You could replace that with a text. Basically, you can choose whatever you put inside OK and inside error, which is really useful. So like, usually the way to go about that is usually with the OK, you want to return like something. For example, if you are coding like a transaction from the ledger, you want to return maybe the block, like the ID of the block, or the ID of the transaction, or the balance, or whatever. You want to return something. And then for the error, you usually create a type that is type error, and then you put like all the possible errors. So like, usually you use a variant type, which is really useful. So like, you do restricted, not found, maybe, I don't know, no cycle, no users, and you add those errors. And that way, when you receive an error on the other side, you can do a switch case, and then you can act based on the error that you receive. So that's really useful. Yeah, when you send an error to someone, it's either gonna be you or some other developer, but it's really cool to be able to like give more information about the error. Of course, it's gonna help everyone, because when you just have an error but you don't know like why it's not working, that's probably a bit annoying. So yes, basically what this code is doing, I just have a hash map to store users. So users are identified by the keys of type principal, and they have a name. So they just have a name. It's really basic. And I can add a username. And then I have this function, which is rename, and it's gated. So I think this canister is called errors. Yeah, so it's gated. I can only call if I am the owner of the canister. And then I can rename if there is a user that is here, I can change his name. But if he's not here, I cannot do it. So it will return not found. I can maybe just do like a few calls. I don't remember what identity I'm using. Okay, so I first need to call errors and add username. Okay, so I have this username. And then I just want to rename it. So let's say I want to rename. Oh, wait, I need my principal. So like, yeah, one thing that is a bit annoying with DFX is that you're using the condict syntax here. So for example, if you want to have a principal, you need to specify it like this. I don't really like that, but you don't really have the choice. Oh, it's not the good function. Oh, that's really funny. I sent this function, I call this function add username, and I put 2 arguments, and you can see the beauty of Candid, which is the interface language. It will drop, if you have more arguments than needed, it will just drop them, and it will not throw an error. That's really useful if you upgrade a canister, and like you have, okay, so you have a service that depends on another service, and the other service is expecting like 3 fields, and then it removes 1 field. It's just expecting 2 fields anymore, but you are still sending 3 fields. It's not gonna cause issues. It's gonna be okay, because like as long as you have what is needed, the service will be like this other service will do its job. And Candid is trying to limit the like number of time that upgrading will broke something. So if there is more arguments than needed, it's cool, and you can just throw them. I don't know if that's really clear, because we haven't really talked about that before, but I just wanted to precise it. So the fix call error rename. So let's say just gonna change to this. I'm gonna paste that. Yeah, apparently I don't have the right, which is okay because I think that's the other identity that deployed it. So yeah, I mean, I think we have seen everything about this example. So I'm just gonna check the chat and see if we have question. Oh wait, where is the? It's there. Yeah, prettier work from Motoko. So someone sent a prettier plugin Motoko. When I use the keyword shared in Motoko, I think you can remove it. Like if you don't want the color, you can remove it. But when you want to access the color, so the person calling the function, you want to know its principal, basically, you need to have the shared keywords. I'm not sure exactly why, like you cannot just like have the color, but that's the syntax. When you declare a public function in your main.mo, it's always going to be shared. So you don't really need, like, if you just don't care about the color, you can do that. I think we've seen this syntax before. Yeah. So like, of course, this is broken, but it's not broken because of the syntax. Like you can write that, it's totally fine. But as long as you want the color, you have to add shared. And I don't really know why, to be honest. So one last thing, what's the difference between actor and actor class? Well, it's like, I mean, you can have, we haven't really talked about that, but you can totally create classes for actor and generate them. So like that could be the case when you deploy a lot of canister. Like I know that a lot of applications that manage multiple canisters, they have a class of canisters. So they define the interface really precisely, the methods they have on it. And actually, I think we can remove the class here. I'm not sure. Okay, no, we can't. Okay, so that's a good question. I don't know why here we really need these keywords. Yeah, I don't really know. That's a good question. Should check that after the lecture. On the error things, I wanted to show one last thing is, so we have the result type that we've seen, and this is the way to go about error. But there is one other way, which I don't have code for it, so because I've never really used it, to be honest, but it's on the documentation. I wanted to mention it. It's you have this error module. So, oh wow. Did we broke internetcomputer.org? Or is just my connection, maybe? Okay, so there is a error module which is different from the results. And this is where you can throw errors and you can do also try catch. But I know that it's really like used in other programming languages, but in Motoko, we don't use it a lot because it's only for asynchronous context. So like you cannot do it for when you're working inside your actor with like normal function, but when you call other actors, you can use the try catch. The try catch I use a lot. When you, basically when you call an actor, like you await something like give me add user, give me something, and you await on the results. You don't really know if the canister is gonna like send something or just throw an error. So you can catch it like this. And then on the canister side, if the on the other canister side, so the callee, the one that is being called, if the person has correctly like implemented the error, you will be able to catch it. But yeah, you can read this section. It's like a bit, I think, I don't really like the way it's explained, but it basically means that you can't really use try catch the way you are used to if you are coming from like, let's say, JavaScript. So yeah, just wanted to mention that, but I don't use that a lot. When we upgrade, the stable data struct survive, but what makes them different to non-stable? And also is, okay, yeah, there are two questions. And also, is the data stored in a canister binary, like a string literal or something? I haven't found more info. So there are a lot of things to talk about. Like if you really want to go deep into that, it's how the canister is implemented, like with WebAssembly. So there is a runtime, which is wasm time. It's a 32 bits runtime. That's the runtime of the canister. And this is 32 bytes, so you have only 4 gigabytes. This is the heap, and this is the non-stable data. So whatever is here will be erased when you upgrade. And yeah, right now it's limited to 4 gigabytes, which shouldn't be the case at some point because there will be wasm time 64 bits. But right now it's limited. And then you have another like abstraction, which is the stable memory. And it's basically an API that is like one level, like it's not in the runtime. It's like the runtime will call this API, which is the stable memory. And then you can store a lot of things. Like it's 48 gigabytes at the moment. And you have basically this memory is not like it's stable, like it's not erased when you upgrade. And yeah, I don't know if that's a good explanation. Like that's just the way it is, but you have those two memory. It's the way the canister are implemented. And experimental stable memory. So that's the API I was talking about. So you have the runtime. You imagine your canister is running. You have the heap. And then you can call a stable memory with this API. So you have this in Rust, but you also have this in Motoko. This is experimental, so it's probably going to change, but you can basically just put binary or like bytes or like nuts or like numbers in WebAssembly pages. It's a bit like you don't have really, I mean, now we have packages, I think, so you can use those packages, but if you go to like the real API, you just have those pages. So it's WebAssembly pages, 64 kilobytes, and you can put a number into it, and you can just do like store information like this. Yeah, I hope that answers the question. You can go really deep with those topics. I think if I provide the links, you can read a lot about WebAssembly and how it's implemented. Okay, I send cycles between canisters or wallet. Okay, cool. This is the next and the last topic of today. So this is cycle management. So I think I'm gonna go step by step on this. So let's say we want to know our balance. That can be useful. So there is a cycle. Again, it's experimental, but this one is, I don't think this one will change too much, to be honest. Maybe they will add more functionalities, but it hasn't changed since they've launched it. So this is a module that you can use, and it's basically all the cycles functionalities that you can access in Motoko. The most basic one being the balance. So let's implement it. No. So this canister is called cycle receive. Yeah, so we have implemented the balance, so we can check it. See cycle receive. And right now we are on the local replica, so the cycles are not like real units, and I don't really know what determines this number, but I know that you can add more cycles if you need to into your canisters. Oops. I think it's ledger, maybe. Yes, you have this command fabricate cycles. So of course it's only locally, so you cannot create cycles in the mainnet, but locally you can create it as much as you want. Fabricate cycles and deposit them into the specified canister. So actually I've never used this command, it's pretty new. I'm just gonna look at the options. So amount canister. Okay, apparently you can just cycle, it's called cycle receive. And if you don't specify any amount, it's gonna apparently send 10 trillion cycles. Yes, cool. So cycles are always talked about in trillions because 1 trillion is 10 to the power of 12 cycles. It's basically $1, a bit more than $1. So that's not a lot. And yeah, so we had the balance before, which was this, and we just added 10, so we can also verify with the function that we have. Yeah. You've noticed that like the number is like is lower, even though we haven't run any operation, because your canister is always going to pay for like just living on the IC, taking some memory and some space. Query are free right now. It's not going to be the case like forever, even though I think query will be very cheap, but yeah, right now it's completely free. And there are more information about cycles, like there is a whole page with the costs. It depends on the WASM instructions. It's very precise how it's calculated. It depends on the subnet type. If you have more nodes, it's gonna be more expensive and stuff. But let's move to more practical cycle things. So what I wanted to show today is that you can send cycles between canisters. And you can do that with the cycle module. Oh, maybe before that, one thing that I want to say is that if you expose your cycle balance, it's not a good thing to do. You should add like the thing we've seen before, so like the assert with the admin functionalities. Because if you expose your cycle balance, someone is going to be able to basically call your methods, like the public methods that you have, and check how your balance is moving. And that's really powerful information to like create a cycle draining attack. This is an attack that could be possible in theory. So that would be like someone spamming your canister and calling the functions that takes a lot of cycles. And the goal would be to put your canister to 0 cycles or to the freezing threshold. And I don't think we've seen like real example happening live, but I know that it's one security concern of the IC. So there are a lot of ways to like prevent that I won't go into, but it's important to not expose your cycle balance. Okay, so what I just wanted to do is that we have two canisters. The first one is it's called cycle receive. So this canister is gonna receive the money, and this canister is gonna send the money. So just have the code ready. I just need the principal, which is the principal of this canister. So I think we can get the ID like, yes, the FX canister ID, cycle receive. Wait, maybe it's not deployed. I'm just gonna deploy everything. Oh, of course, this. Okay. So you can see the canister ID here. We're looking for receive, so it's this one. Oh. Okay, so we don't need that. So what I'm doing here, I'm doing a lot of new things. I think we haven't seen like intercanister call yet. So I'm defining the actor, which is this one, and I'm defining this interface, which is a function pay order, which takes nothing and returns a result of text or text. And actually, I don't need to talk about this function. I don't really care because I just want to call this one. So when you define an actor, like inside another actor, you can just add the methods that you need. You don't need like to copy the whole interface. You can if you want, but since we are just gonna call this function, we don't really need to. So what I'm gonna do is I'm gonna call the, sorry, I'm gonna call the pay order. So like this function will take a bool. If I say that I want to pay, I will use cycles.add, and I will add cycles to my message. So when you set messages on the IC, like between canisters or between users and canister, you can attach cycle on the message. So what I'm doing here is that I'm saying to my canister is that the next message will add that amount of cycle on it. And then I'm calling the pay order of the receiver canister. And then the canister that is receiving the money or the cycles is gonna check. So cycle available is basically checking how much cycles are available on the message. If it's more than the price, we have a price that is defined here. If it's less than the price, it's just gonna say not enough. And if it's more, then it's just gonna accept. So it's gonna add the cycles into its balance and return the order. So like just this thing, but I think you got the point. So if I think if I call it right now, the price is 1 billion cycle and we have 900 million, so it shouldn't work. So let's try. So the fx canister call cycle send get order. True. Maybe I think we haven't deployed this yet. Yep. So as you can see, it was not enough. So maybe now I can add more cycle. So like, wait, how much was it? Yeah. Maybe we should add just a bit more to be sure. And thanks, here is your order. So that's pretty cool, to be honest. I haven't seen a lot of like use case for that, but I think it's really interesting that you can send so easily like money between services. It's gonna, I don't have a clear picture, but I think this is really interesting, like how you can incentivize maybe services to use you, or like, I don't know. I think there is something to do with the cycles. How the way it's set up is really cool on the IC. And I just wanted to show you that. Yeah, I think that's about it for the cycles. And you can also use that. One pain point about the IC is like you have to monitor your canister and make sure that they don't run out of cycles. This happened to me for like some of canister that I deployed, and that's a bit annoying. Usually you have by default 30 days. It's called the freezing threshold, and it's basically gonna freeze your canister. So canister will not be able to answer any request, but it will save its state. And you have 30 days to like top up the canister and get your state back. But if you pass the 30 days, then the canister is just gonna be deleted, which is a bit like annoying if you have something cool. So the way to go about that, I think there are some tooling labs working on it, but I imagine that the most common pattern right now is like you have a main canister that is like you fuel it of cycles. It's like your bank basically, and then it's going to check all the canisters that you've deployed like regularly, and if one of them runs out of cycle or like is low, you just send more cycles from the bank. And as long as the bank is like fueled, you should be good for all the cycles, all the canisters that you deploy. No notification when they run out. So no, not by default. I mean, like the IC doesn't really have a way to send you notification. There is HTTP request, which was released like a few months ago, but by default, the IC doesn't have a way to really send you notification. So I'm pretty sure that someone is working on something. And in the next few weeks or months, we'll see like cycle management things where you can receive like SMS or emails when it's running low. But I think right now there is no solution. How is it possible to call pay order in cycle send.emo? How is it possible? Oh, we are defining it here actually, this line. So maybe I should write it like this. I think that will be more clear. So yeah, I've quickly passed on that, but it's really cool the way you can import like actor in another actor. So you just use the keyword actor and you put the canister ID, and then it's just gonna enable you to talk to another service, so to another actor. And here I've also added the interface, which you need to do. You need to know like what is gonna be the type of like the arguments and the returns parameter. But then once you have this line, you can just do await the name of the canister, so we call it shop, and the name of the method, and that's it. That's how you call like another service. That's one like key point of the IC. It's like this really easy thing about communicating between canisters. That's pretty cool. Yes, so in summary, you created an actor B in another actor A that fires a lambda on creation to pay the actor. Not on creation. I'm not sure. I just have to call this function to like send the money. It's not really on creation, but basically that's the idea. I think I've talked about everything I wanted to talk about. So there are more questions in the Q&A. Sorry, I was just looking at the chat. Who gets paid? So this is the canister that I've called the receive that gets paid. This one send because it adds cycles into the message. And this one is paid because it will accept like cycle.accept. It will take the cycle on the message. So this is this canister. And if you want more info, just go on experimental cycle. And again, I don't really like the way it's explained. It's like, I don't know. It took me like a long time to understand what they mean. But if you just do some local tests, you have all the functions on cycle here. I will give you more information. I will share that repo, sure. Just need to push it. Oh, there are a lot of questions. I wanted to show more things on the core project. What's our state changes reverted if an exception occurs? I think yes. They are reverted to the latest commit point. So whenever you have like an await, the canister is committing its state. So like let's say you do like you modify the balance of a user, then you call something, like you do await and you call another service, then the state is committed. And if you have an error when it comes back, the state is not like rolled back to, it's not rolled back because you have this await. I really recommend to read about that, like commit points is really important. Commit points. Drop some commit points. Is it this though? Yeah, it's this. Is it possible to catch trap? Does it stop the service or container? It depends on the context. It's possible in some contexts if it's asynchronous, but yes, it will stop the service, but like just on the message, it will not stop. Like it will just stop the answering your request. Like if you send a message, just not answering this request, and the canister that sends the request or the user is gonna receive this error or this trap, but it will not like you don't have to restart your canister if you just trap. Wouldn't the canister principle change between local and mainnets? Yes, of course. So that would be like you could have probably, if we do that like properly, you would have a file like and you would just say like let canister canister ID like local equal this, let canister ID mainnet like this, and you would probably have somewhere where you instantiate your actor, you would say like mainnet or IC, and then you would be able to like programmatically know if you are calling like the canister that is local or on the mainnet. I think I can find some code for that as well. Yeah, I have another question on environment variables for canisters. Let me think about. I think you should ask this question on the ask question feature of Discord. I have I have a few patterns in mind, but I'm not sure this is the best way to go. I think it was a bit messy when I was doing it, so there are probably better ways to do it. If all functions of a canister are gated, let's say using internet identity, how could one go about defending against denial of service, draining canister cycles? If all functions are gated, so like if you check the principle in every function, I'm not sure I got the question, but I can like expand a bit on cycle draining. You have a lot of ways to defend about that. You can like basically store how much like a principle is calling some methods. You can do like a kind of analysis, and you can have it's like limiting rates of canisters. Like you can do that. I think there are some patterns. You can also check the message sometimes. You have this messaging inspection API, which allows you to like reject a message even before the code is processed. So like that's not even going to trigger one line of code. So it's like really, really cheap. And I think if you do that, I don't really see a scenario where the attacker would be like would benefit from attacking you, because it would be so cheap in cycle for you that the person would still have like to send a request and stuff, and that would just not be like profitable for him. Well, there are so much questions today. Considering a running canister A backend, I would like to know if it's possible to dynamically create other canisters. Yes. Yes, of course, you can do that. So like that was the idea when I talk about the actor classes. I don't have code on it, but you can have like a factory and you can create canister on the fly. So that's like, for example, OpenChat is doing this. When they have a new user or they create a new chat, they just create canister on the fly, and they have like a main canister that is kind of responsible to storing all those canister ID that are generated and like keeping track of that, keeping track of the version of the hash that is installed inside the canister and updating that. And usually you would do that with a class of actor class. Yeah, that's the line I was looking for. This line. So like you have this type bucket. Instead of being a type like we've seen before, it's basically a type, but it's an actor. Like it's a canister that you have here, and then you can just store it here. And you can like with this line, it's going to create a canister basically and just return you the information about it. I think it's returning the principal. I'm not an expert on like creating canisters from other canisters because I think I've done it just a few times and I've never done it. I've only done it like once for one specific thing, but not in a factory way where you just generate them automatically. So I'm gonna send this link and you have a lot of information over there. I missed the beginning of the lecture, so I wonder what is share called creator. It's a syntax to get the principal of the person that deployed the canister. I don't really have an explanation of like why it's like this. I don't really like this syntax. I always forget about it and just have to go back to the code to copy paste. But basically, shared is like it's gonna enable you to have information on the message. So the message that is sent when you install the canister, and then you can, on the message, you can do message.caller, and you get the principal of the person that deployed the canister. And this syntax is just like destructuring, so you just get the caller from that. I think Zen, I'm gonna charge you because that's like 10 questions in one session. I don't know. I think there is a limit. DFX.json has remote concept for multiple environment. Can't we just use the canister name? Probably. Yeah, no, yeah, okay. You can do that like with DFX. You can just use the canister name. For example, when I was calling from the terminal, you can use the canister name. But I'm pretty sure that in the case of like this syntax, like having an actor instantiate into one another, you have to use the ID. And I don't think you can get it like, you can get it from even with a good configuration from the fx.json. But as I've said, I think the way I was doing it was not the best. And I think I should update on that. So if someone has like a link or something, that would be cool. If a canister is the controller of another canister, because it created it, how one would upgrade it? You have to upload the WASM inside the controller, and then you can upgrade like this. That's challenging. I know that, again, OpenChat, they had some issues with upgrade at some point, keeping track of the version. I think it was taking like a lot of time to upgrade. Like in terms of, I think we are talking about hours or even days for like upgrading their entire fleet of canister. But I think now it's like you can send more information on the messages. I think we should get OpenChat to speak about that. Motoko Bootcamp token faucet as a repository. Yes, I haven't shared it, but it has a repository. I think I'll put on my list. I'll share it after. Yeah, thanks, Salva. I'm gonna be honest, I think that was a long session, but it was really cool. I think we had a really good question today. Even I wasn't able to answer everything, so yeah, thank you for like all the question. That was cool. So I wanted to talk about the core project, but I think I'll do that in the mentors session because this is already past the hour mark. Thank you guys, and see you to the next one. Have a good one.